So we're going to go through a few things. We're going to take a brief little look back at the wild west that is Android design systems, because we've come a long way. Thankfully, Jetpack Compose is fairly modern, so it's avoided some of those old days, but it's worth taking a look back. And then we're going to dive into material design in Jetpack Compose, which is Google's default design system. We're going to take a look at deviating from this and doing custom design systems. Then we're going to take a quick look at how you can architect your design system to make it better to work on teams and with lots of modules, etc., etc. And then hopefully we'll have time for some questions as well. So, a brief history of design systems on Android. So, we're going from the early days through to Holo, through to material design, so let's take a look at that. First, a timeline. Again, the early days kind of started when Android was introduced 1.0 in around 2008. We got Holo in 2011, and then material design basically took over from there from around 2014 and has seen various iterations and almost like rebrandings over the years. And somewhere along there, Jetpack Compose was introduced as well. So the early days kind of looked like this. Android wasn't exactly the prettiest OS to begin with, to be honest. So Android 1 all the way through to Android 2.3 Gingerbread had this very, how can I say, dated look. The apps were a bit of a wild west situation. The design was all over the place. There wasn't really any clear guidelines as to how to design an Android app back then. However, I am using Gmail as an example throughout this so that you can see how it evolved. Apologies because these screenshots are quite hard to get hold of, so they might be a little bit pixelated. But you can see the first iteration of Gmail on Android was, I'll just say not the best, but it did what it did, and it fitted in with the design of the time. But it's characterized by this very skeuomorphic, gradienty, quite busy design, to be honest. We then moved on to Holo, which came around the time of Android 3.0 Honeycomb and lasted all the way through to Android Ice Cream Sandwich and Jelly Bean, which literally adopted a Tron-like UI. In fact, the promo video for, I think, Holo was literally androids driving on Tron bikes. But you can see these spacey, holographic themes that came into play. I think that really elevated the Android robot-y theme. And Gmail, as a result, evolved to be a little more blocky. The Roboto font was introduced. It's a lot of grays, and iconography was, again, quite futuristic. But then, after that, came material design. Material design is what we still have today, but the first iteration technically was introduced alongside Android Lollipop, but we saw the sort of beginnings of it in Android KitKat prior to that. And it adopted this new metaphor of paper, shadows, ink on paper, a slightly more relatable metaphor and a system to design Android apps that would take them out of this either dated look or a little too futuristic look to something that was more consistent. You can see here how Gmail evolved into something that you may have used. The classic app bar, the folded paper look, the shadows. It's looking a lot cleaner. There's elevation involved, there's layers to it. So this is what material design sort of started as. Material design took a brief sort of evolution into what we call material theming, which in retrospect was actually material design 2. Which material design actually calls it nowadays, but it started off as material theming. The OS didn't change much, it maintained this sort of clean visual look, but the apps themselves changed quite a bit. Gmail evolved into this classic, basically very clean look. It's adopted this Google material theme, and everything was more spaced out. Typography was quite clean, and iconography came to the fore. It was basically an evolution of the original material design to make sure that apps can use material design, but that they feel different to one another. There was initially a criticism that all material design apps look the same. So this was to combat that. Last but not least, we have what we have now, good old Material U, which you might have heard of. This is otherwise known as Material Design 3. This is Google's latest identity crisis, innovation, whatever you want to call it. It's effectively trying to put a fresh coat of paint on Android once again. And this time they went quite wild, interesting shapes, colors that come from the wallpaper, a lot of personalization themes, a lot more rounded corners. Yeah. So Gmail nowadays looks kind of like this. It might look different depending on what the wallpaper is that you currently have on your phone, which is kind of cool. But you can see how the design has evolved, and all of the components have sort of taken on this softer look. So that's design systems on Android up to now. I'm going to now talk a little bit about the implementation of material design in Android, and whether you should think about material design 1, material design 2, or 3. There's material you, material me. It's all a little bit confusing, but hopefully I'm going to clear that up for you. So let's look again at that timeline that I showed you in the beginning. And we're going to zone in on one particular part here, in that material design 2 and material design 3 were introduced basically before and after Jetpack Compose. So it's interesting to note here that Jetpack Compose came in between these two versions of material design, and I'll show you what the implications of that actually are. Material design 2 kind of looked like this, and along with it came a Compose library called Compose Material, which implemented the spec. It gave you all of the Material Design 2 theming, components, and other aspects that you can use in your Compose apps. It's still available today. It's still being incrementally updated. However, the focus has shifted to Material Design 3, which is an evolution of that. It has more components, expanded theming, a different look. And for that, Jetpack Compose has a separate library that you have to add to your app called Compose Material 3. So yeah, you basically have two artifacts that you can add to your Compose apps, Compose Material or Compose Material 3. You'll notice I've added a little preferred label up in the top right, because this is why. Basically, this is the elevator pitch for why you should use Material Design 3. It has new components, as well as updates to the existing ones, and an expanded theming system. It's got some exclusive features like dynamic color, which can pull colors into your app from the wallpaper that the user has set on their device. It also aligns more with the native Android OS look and feel. It's worth pointing out that the Material Design 2 app now on Android 13 feels a little bit more out of place than the Material Design 3 app does on Android 12 and 13. So there's something to be said about that. Obviously, the reverse is also true, which is tricky, and I don't know how to solve that. But the sort of, I guess, behind-the-scenes thing as well is that most of the design and engineering effort within Google is going into Material Design 3, so it's definitely worth your time and effort now that it's actually reached stable. So let's dive into some code. I'm now going to show you a little bit about how you implement Compose Material 3 how to implement Material Design 3 in Compose using Compose Material 3. And the first thing you'd want to do in your app is add the dependency to your app. It's pretty simple. It's just a single line in your build.bagel file. To illustrate how this works, I'm going to be using this composable function that's going to model an entire app. So in the real world, this composable function would include things like your navigation graph, then the individual screens that actually sit in your navigation graph, and then the components that make up these screens, etc., etc. This is all pretty complex, so I'm going to use a drastically simplified version, and it starts looking like this. So imagine this is like an entire app. Obviously, no real app looks like this, but we're going to start off by having this composable just use something called a surface, which actually comes with the material library. As the name would suggest, it provides a surface on which to put other things. And within that surface, we're going to use a column to vertically lay out some other components that I'm about to show you. Those components are a bit of text, a button, and a text field. These are all stock Material Design 3 components, and at the moment, they're the stock look and feel that you would expect if you were to use them out of the box. So this is our entire app. Again, vastly simplified, but we're going to use this throughout to illustrate how to apply theming and use Material Design 3 in your app. So the idea here is that you've got this app content, in our case a column and a surface and 3 little components, and you need to wrap that in something called a material theme. This material theme provides theming values to those components, but just using it as is like this isn't going to do much. What you actually need to do is edit the material theme and basically pass in custom theming values so that the components themselves change and adapt to these theming values and change how they look. Here's an example of how to do this. In my case, I've chosen to go with this green Android color, these sharp corners and the shapes, and then this Roboto mono font. And here you can see that the parameters that material theme accepts are a color scheme, typography, and shapes. That's all it accepts. And these three things basically model the various parts of your design system's theme. So in theory, you can make components from material design look entirely different if you change their colors, if you change their typography styles, and if you change the shapes, like the roundedness of their corners, or whether their corners are cut, and stuff like that. And I think it kind of works. This does look quite a lot different to the one before. But let's take a look at those things: color scheme, typography, and shapes. So a color scheme is really just a class that is strictly typed. It has, I think, 25 different color values, and these color values are intended to serve different roles. One could be more for like the background of buttons, one could be more for the background of your app, one could be for content like text. So you effectively instantiate a color scheme by using these light and dark color scheme functions to create these objects and passing in custom color values that you ideally have gotten from your designer or that you've come up with yourself. Again, it's worth mentioning that you use light and dark color schemes because for color in particular, you do have to think about whether your user's in a light theme or whether your user's in a dark theme. So again, dark theme considerations in Compose is fairly simple. You check if the user is using a dark theme, you then switch between your light and dark color scheme. And then you effectively set up a custom color scheme to pass to your material theme. Here's how I've sort of tried to illustrate how this works, in that by passing a custom color scheme to my material theme, the components themselves reach into that custom color scheme, pick out various values like primary, on-primary, surface, etc. like that, in order to color themselves. And by changing this color scheme, the components themselves change as well. It's worth noting here that I mentioned dynamic color and colors from the wallpaper. Just a quick aside, seeing as we're on the topic of color. I know this looks like a fair bit of code, but really it's kind of the same as, or it's very similar to switching your color scheme depending on whether the user's in light theme or dark theme. Only this time you check if the user has dynamic color available, which is only on Android 12 and above, and then use that to decide whether you want to create a dynamic dark color scheme or a dynamic light color scheme instead of the branded ones that I showed you before. And in doing so, your app can actually pick up colors from whatever the user's wallpaper is and changes when they change that wallpaper, which is quite a cool experience. Lastly, this is how you set up typography and shapes. These are also things that you pass to the material theme. In my case, I've overridden certain text styles like body large, label large, and then extra small and large shapes. These apply to the components which also read from these values and change, let's say, their text label or their corners depending on what you've set here. So that's material design in Compose, material design 3 I should add, in a very brief nutshell. But we do have a lot more on this. So there's a lot of guidance that lives online on Material Design 2 and 3 in Compose. There's actually a migration guide if you were already using Material Design 2 in Compose, if you got in there earlier with Compose and then Material Design 3 came out. So we've written a migration guide for folks to use as well. And then there's a page which is basically a big API reference which has a table of like, these are all the components you can use in Compose Material 3. This is how you set up theming, etc., etc. So hopefully this is enough for you to get going and delve in a little bit deeper into the things that I've touched on today. Next up, custom design systems. I think most apps that I've worked on, most apps that I've seen, don't use material design as is out of the box. At the end of the day, they tend to deviate in some way, maybe a little bit, so that they add maybe a different color that isn't in the material design spec. Maybe they add a custom component that isn't in the material design spec. It varies per app, per brand, and per use case. So we're going to take a brief look at how to do that in Compose, because the material design app is intended for you to use it almost as the standard material design spec, but in reality, most people actually need to deviate that from that a bit and do what we used to maybe call in views and XML as custom theming. What use cases are involved in custom design systems. So in my case, I'm going to touch on two things. It's going to be adding custom theming values on top of the existing material theming values that exist in color scheme, typography, and shapes, as well as wrapping material components in your own composable functions, which makes using these custom theming values a bit more pleasant in a big code base. You can do other things like adding completely new classes and whole new systems of theming that go outside of these. You can also do entirely custom components that don't even use material design at all. Those are all documented, but today we're going to focus on those two use cases I mentioned initially. So in our case, we had that really big app of the button, text field, and text. And let's say that our designer has said to us that, okay, I know what colors are in the material design color scheme, but I actually want to add 2 more colors to that specifically for buttons. We don't want buttons to use the primary color anymore. We want to create their own color for buttons so that, I don't know, design reasons. So in this case, I've tried to illustrate it here using an extra few blocks on the side of the existing color scheme. How do we do that in Compose? We start off by creating a class to model this. The color scheme class in Compose Material 3 is strictly typed. It has 25 values. It's also not an open class, so you can't extend it and do basically inheritance in that sort of way. That's by design so that you use the material design library according to that spec. If you want to add custom colors, you need to make your own systems and classes to do that. So what I've done here is made a button colors class that simply models the 2 colors that I showed you in the previous illustration. So we've got button and on button. It's pretty much going to be the color for the button's background and then the color for the text label in the button. What you then need to do once you've made that class is create a composition local of these button colors. Composition locals is a fairly complex topic. There's a lot of documentation on it, but effectively it's Compose's way of passing values around that don't act as parameters in all of these composable functions that make up your app. So you can skip past having to pass down a value through, I don't know, as a parameter down multiple levels of functions. Once you've made those, you can then just construct instances of them. Here I've made a light button colors and a dark button colors. I've used my dark theme option again to decide if I'm going to use the light or dark one, and I've created an instance of button colors. What I then do is use composition local provider. This is a thing to provide composition locals down to everything in the Compose hierarchy so that they can pick up those theming values and use them if they want to. This is done basically outside of your material theme. You still want to have your material theme there so that you can provide all the existing material design theming values to the rest of your app, but now you're providing extra ones. And then, when you get to your button composable, which is in our app, we simply override the colors to use these custom theming values. You can see here that I've used local button colors.current.button and on button for both the container color and the content color. What this does is make our button yellow, but you'll notice that the other colors from our color scheme, that Android green and the Roboto font and the sharp corners, are all still there with our app, except just our button is using the custom values. However, this is quite a lot of code, especially if you're going to be using this button in various places in your app, which is almost very likely for basically any app. So you don't really want to be doing this where you override the colors every single time and have this, 10 lines of code in place all around your app. What would be better is to wrap the material components to make them easy to reuse. And there's a few steps to this that I want to outline before I show you. So step 1 is to wrap the components in your own composable function, expose only the necessary parameters, internally set any parameters that override the theming values, and then you end up with less code at the call site and it's all more consistent. I'm kind of running out of time, so I'm going to rush through this. Here's my app button, simple composable function to model the button you just saw. What I do is I expose only the things that people would really want to change, the on-click listener and the content, which would be like a text label or an icon. We then call the material button inside this function and pass through the on-click and the content so that it receives those, but internally set the buttons and don't expose that as a parameter that someone else would want to change. This makes it easy to basically go from this, which is what we would have in all places where we have buttons in our app, to this, which There's a lot less code and means that there's going to be consistency throughout your app by wrapping the component. There's a lot more custom design systems available. There's documentation, some of it's getting updated. But I want to quickly move on to the next section because I do want to show you these things about architecting your design system. I think this is the most interesting part of this presentation, to be honest. It's basically making your design system easy to use on a team of Android developers and designers and make it such that it's more maintainable and usable. What do I mean by this? Good old modularization, testing, but then other cool things like custom lint rules as well as catalog apps. To illustrate this, I'm actually going to be using a different example. This is the Now on Android app. It's on GitHub. The Android DevRel team, my team at Google, maintains it on GitHub and then also has recently shipped it to Google Play. And I contributed to the design system module that lives in this app. Modularization is modularization, but here you can see an illustration of how the design system module lives within the hierarchy of other modules within this app, which include features, but other core things like data stores, and other parts of the UI. We tested the design system, so we set up unit tests as well as instrumented tests to test things like theme configurations and various things and components in terms of how they react and how they look. We set up custom lint rules. This is, in a nutshell, to try and prevent people from using material button directly instead of our NIA, Now on Android button, the wrapped component, using the same approach that I showed you earlier, all over the app. I mean, people were doing that basically. They weren't aware that the wrapped component was available, so they ended up accidentally using some of the material components directly. Lastly, we built a catalog app, which is for other team members to see, okay, which buttons or which components are available, which have been styled, like how do I use them? By wrapping components, you're effectively creating new APIs for your team members to use, so this catalog app can be a great way to see how to use those and interact with them on a device. Thank you.